So, good morning, everyone, and welcome to today's lecture. This is lecture number 2 in rigid bodies or rotation, and we will go ahead with our discussion from the last class. Can anyone recollect? Remember what we had discussed in the last class yesterday? In the last class, what did we had discussed? Anyone knows it? Anyone remembers it? What was the topic of discussion in the last class? Hmm?
Pure translation, rich bodies.
Yes, we were trying to discuss the difference between translation and rotation. We had seen pure translation, all the particles of the body, everyone is moving with the same displacement, everyone has the same displacement, everyone is moving with the same velocity, everyone is moving with the same acceleration. That type of motion of a rigid body, which can be considered as the motion of a point, is known as pure translation. Whatever we were doing up till now was pure translation. The body was changing its position only. That was pure translation. We understand this? Yes or no? We remember this.
Yes, sir.
Then what are we going to study here is rotation, and we had also seen one more way of understanding rotation. If the body changes its orientation, the body is like this, then it becomes like this. If it changes its orientation, that means it has rotated. When the body is in pure rotation, then what happens? All the particles of the body, they move in circles. The centers of all these circles lie on one line that is known as the axis of rotation. They have the same angular velocity, angular displacement, and angular acceleration. And this pure rotation can be thought of as circular motion of a single particle. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone knows this up till here. Now, what we will do is today, as I told you, when the body was changing its position, we had done it as pure translation. Up till now, whatever we had done was that. Now, we have also done pure rotation. We have not done it's in pure rotational motion, but we had done it as circular motion. So, whatever we had done in circular motion, and I repeat, whatever we have done in circular motion can now be taken and understood as pure rotational motion. Yes or no? Do you understand this? Because the body is going to move, going to have a pure rotational motion. Now, when the body is having a pure rotational motion, that is nothing but it is same as a particle moving in a circular path. Same terms will come. Same terms will come. So the first term that is going to come is known as angular displacement. Do you remember angular displacement? Do you remember angular displacement? Do you remember angular displacement? Anyone?
Sir.
Yeah, so the same term will come, angular displacement. So write the heading angular displacement. Angular displacement. Angular displacement. When the body rotates by a small angle, we call the small angle delta theta as angular displacement. We remember this, yes or no? Now this angular displacement, let us have a quick recap. The SI unit is radians. Do we remember this SI unit radians? Yes or no? Dimension. Remember it has zero dimension, no dimension because angle has no dimension. Do we remember this? Do we remember this? Now, is it a scalar or is it a vector? So small angle d theta, small angle is a vector. I hope you remember it. But if the angle is large, delta theta, it is a scalar. So for small angles, it is a vector, and for large angles, large angular displacement, it is a scalar. Do we understand this? Yes or no? No, yes. Okay, one more thing. 2 pi radians is equal to 180, oh sorry, pi radians is equal to 180 degrees. Do we know this relation also? Do we know this relation also? Yes or no? No, yes. I'll give you 2 minutes to note it down. 2 minutes, note this down, everything. So, we have seen a sign convention also, and if you remember that sign convention, if you are moving like this anti-clockwise, oops, if you are moving anti-clockwise, that angle is taken as positive. Do you remember this? So you can also note this down. Anti-clockwise is taken as positive, whereas if you are moving clockwise, clockwise is taken as negative. Do we remember this? Yes or no? Anti-clockwise is positive, clockwise is negative. So you can also note this down, bacha. So this is a quick recap of what we had already done. Now, the next thing was angular velocity. We denoted it by omega. Do we remember angular velocity? Omega. Yes or no? No or yes? Angular velocity, my dear friends, omega. We remember this? Angular velocity. So now if it is if the body is rotating, it will be rotating with an angular velocity. Now instead of writing the angular velocity here, what I will do is, this is a disk. It is rotating with an angular velocity like this. So now I have given it like this. Do we understand? Angular velocity. Angular velocity like this. Now what is angular velocity? First, listen to what I am saying. I'll I'll give you all the points. Then after that, you note them down. Okay? I'll give you time to note them down. What is angular velocity? It is the angular displacement per unit time. Do we remember this? Angular velocity is angular displacement per unit time. We all should know this and should remember this. Okay, that is point number one. Now, what we had seen was, we had seen two types of angular velocity. One was known as instantaneous angular velocity, and the other one was known as average angular velocity. Just write it. Just know. Listen to me first, then I will give you time to write. One was known as instantaneous angular velocity. The other one was known as average angular velocity. Instantaneous angular velocity was d theta by dt. That is instantaneous at any instant. Do we remember this? At any instant, instantaneous angular velocity. Then we had our old friend, your average angular velocity, which was total angular displacement divided by total fine. Don't forget it, my dear friends. That is the next thing. Now remember, this average, this instantaneous angular velocity was a vector, whereas your average angular velocity was scalar. Do we remember this? If you
Yes,
don't
sir.
remember this, you can note it down. Not a problem. Not a problem, my dear friends. Not a problem. Not a problem. Then the unit is radians per second. The dimension, you can also note down the dimension if you don't remember it. Now in vector form, you can write it as omega cross r, where omega is your angular velocity, and v is your linear velocity. Okay, so this is the vector form in which you can, what is happening? This is a vector form in which you can write this. And then we had seen the relation between omega. I will write that relation. Time period is 2 pi by omega, for, and that is equal to 1 by f. Do you remember this relation? Do we understand this? Do we remember this? Everything about angular velocity?
Yes, sir.
Again, if the angular velocity is anti-clockwise, I will take it as positive. If it is clockwise, I will take it as negative. Now I'll give you 2 minutes. Take your time and now write it. Once you are done, please let me know. And let us move ahead with the next thing. We have done angular displacement, revision of angular displacement. We have done the revision of angular velocity. What will be the next thing that is going to come? Yes, my dear friend. Yes. Tell me what is going to come next? Huh?
Acceleration. Angular acceleration.
Angular acceleration. That is absolutely correct. So write the heading angular acceleration. Angular acceleration denoted by the legendary letter alpha. What was angular acceleration? It was the rate of change of angular velocity. I hope all of you remember this. Rate of change of angular velocity was angular acceleration. Please first see and hear what I'm saying. Then I will give you time. In that time, you can easily note things out. There are two types of angular acceleration that we would have discussed. What were the two types of angular acceleration? Tell me.
Average angular acceleration.
And
In instantaneous.
instantaneous angular acceleration. Instantaneous angular acceleration is your angular acceleration at any time. Right now, what is your acceleration? D omega by dt. Average angular acceleration is change in angular velocity divided by time. Now remember, both of these are vectors, so you don't have to worry. Both of these are vectors. Do we understand this? Yes or no? No or yes? Uh, it is a vector quantity. The unit is radians per second square. Do not forget this. The dimension is m0 l0 t minus 2. Now if alpha is 0, then the motion, rotational motion, is said to be uniform rotational motion, uniform circular motion, uniform rotational motion. And then we have a relation between acceleration and angular acceleration.
Hello.
Yes bacha, what happened? Anything that is troubling you, beta? Everything is okay? Everything is okay, beta? Okay, so please note this down. I have done thing. I give you time. Note this down. So what we have done is we have seen what is angular displacement, angular velocity, and angular sorry acceleration. What we will now see is the equations of motion, and we will try to keep both the equations side by side so that it's a revision of what we have done previously. You remember the equation of motion, v is equal to u plus at, and all those equations. Do you remember those equations? Yes or no?
Yes, sir.
Now The equation of circular motion, or equation for that matter, if I call rotational motion, will be same as circular motion. So now you can have a look at this equation first. Please listen to me, then only you go and write. I will give you enough time to write equations of motion. So again, this is probably the last time that we are going to go through all these equations. So please have a look at this. The first equation, if your acceleration is 0, then the velocity is constant, and you can say s is equal to, or displacement is equal to ut. We understand this. There is no acceleration, so half at square goes away. Similarly here, if there is no angular acceleration, will omega will remain constant, uniform motion, uniform rotational motion, and your theta will be equal to omega t. Now the second set is when acceleration is constant, you can write displacement as u plus v by 2. That is first equation. We have not done this as the first equation. We have done v is equal to u plus at as the first equation, s is equal to ut plus half at square as the second equation, and v square is equal to u square plus 2s as the third equation. Yes or no? This fourth equation is the equation for displacement in the nth second. Yes or no? Now these two equations that are here, this blue equation is actually same as this one. Do we understand this?
Yes, sir.
And this first equation, if you want to remember it, you can remember it. If you don't want to remember it, well, skip it, because you may not need it. Similarly, this is the first equation, omega 2 is equal to omega 1 plus alpha t. Omega 2 is the final angular velocity, omega 1 is the initial angular velocity, theta is the angular displacement, omega 1 t plus half alpha t square. Third equation is omega 2 square is equal to omega 1 square plus 2 times alpha into delta theta. The fourth equation is displacement in the nth second. This equation is exactly same as this equation, but written in a different form. If you want to remember this equation, you can also remember it. Do we understand all these equations together? Yes or no?
Yes, sir.
So this is again a revision of what we had done till the first day, till now. I'll give you 5 minutes. Note down this, and leave more column, because there's one more thing that is going to come up. So make 3 more rows that will also come in the next page. I'll give you 2 minutes. Note this down. Let me know once you are done. And let's move ahead. These are the equations that we have seen if the acceleration is constant or angular acceleration is constant. You can also write the other equations which are valid when it is variable. We may not actually require them, but this is just for your understanding of the entire topic. So if the acceleration is not constant, you can write velocity is dx by dt, omega is d theta by dt, acceleration is dv by dt, angular acceleration is d omega by dt. These two equations are good enough. If you want to write, you can write the third one as well. You can write v into dv is a into ds. V is velocity, dv is change in velocity, a is acceleration, ds is the small displacement, and we have similar equation here. You may not write this, it's not required for your side. You can just write the first two equation. I hope you know what you're writing. Yes or no? I'll give you 2 minutes. Note it down. I think you can note down faster. Have you noted it down, bacha? Shall we move ahead, beta? Let me tell you or ask you this problem. What is the angular velocity of the second hand of an watch? These questions have come many times. So, can you tell me what is the angular velocity of the second hand of a watch? Yes. How will you find it out? Any idea how will you find it out? In 1 minute? And how much is 1 minute? 60 seconds. How much does it move? Seconds and in 1 minute, how much does it move? It moves 360 degrees, and 360 degrees is 2 pi radians. So in 60 seconds, 1 minute, how much it moves is 2 pi. Now I can use the formula omega. The angular velocity will be, there is no acceleration here, so it will be theta, the angle moved divided by time, 2 pi divided by 60, and my dear, your answer would be pi by 30, because the unit is radians per second, so you have to find out how much angle it moves in 1 second. So the angular velocity of the second's hand, the hand of a second of a clock, is pi by 30 radians per second. Do we understand this? Okay. Have you noted this down? Okay. Then you can tell me the next thing. Find the angular velocity of minute hand. What is the angular velocity of the minute hand of a clock? How will you find out the angular velocity of the minute hand of the clock? Can anyone tell me? Yes. How will you find out the angular velocity of the minute hand of the clock, beta? Yes. Anyone? Shall I do it? In 1 hour, that is 3600 seconds. The minute hand completes one revolution. One revolution is 2 pi radians. 360 degrees. One revolution, 2 pi radians, 360 degrees. So omega is the angle turned divided by the time taken. There is no angular acceleration here. Angle turned is 2 pi. Time taken is 3600 seconds. So it is pi divided by 1800 radians per second. Do we understand this? Great. Great. I hope you have noted this down, everyone. Okay. Let me now ask you third question. A wheel rotates at 1200 RPM. What do you mean by RPM? RPM. Anyone has heard this term RPM? RPM. Okay. RPM means revolutions per minute. RPM, revolutions per minute. RPM, revolutions per minute. A wheel rotates at 1200 RPM. Find its angular velocity omega. What will be the angular velocity of this wheel whose that is rotating at 1200 RPM? 1200 RPM. How will I find it out? How will I find out angular velocity omega from RPM? Anyone, any idea? How will you find out omega from RPM? So you can make a small formula, angular velocity that is omega will be equal to 2 pi by 60 multiplied by RPM. Whatever RPM is given, to find out angular velocity from there, you can multiply it by 2 pi by 60. Why do you multiply it by 2 pi by 60? Because in 60 seconds, it has 1200 or 1500 RPM. And in 1 RP, 1 revolution, it rotates 2 pi. So when you multiply this 2 pi by the RPM, you get the angle turned. And once you divide it by the time, this is angle divided by time, and angle divided by time gives you the angular velocity. So you can remember this formula. As soon as I put this formula here, omega for this will be 1200 multiplied by 2 pi by 60. Instead of writing it like this, you can multiply it by pi by 30 also, because 2 will get cancelled. Anyways, this is the way I remember it. So now you can see that this will be 40 pi radians per second. Do we understand this, how I have done this? Okay. Have you noted this down, everyone? I'll give you a small question before ending the class today. I hope you can give me the answer fatafat. Question. A wheel rotates at 1800 RPM. Find its angular velocity omega. Can you tell me the answer for this one, my dear friends? The rotation is 1800 RPM. Quite fast. I must say.
Sixty pi radians per second.
Well, that is very quick. Well done. So you just have to put the formula. Omega is 2 pi by 60 multiplied by your RPM. So I put the formula omega as 2 pi by 60. I can write it as pi by 30 multiplied by 1800. 1010 goes 60 pi rad per sec is the answer for this omega. Well done, everyone. Now, since you have done this, I was not planning to do this question today, but since you have come so far, and there is a question waiting for you here, and I would be very glad if you can give me the answer for this one. A wheel of a car is rotating at 1200 rpm. On pressing the accelerator for 10 seconds, it starts rotating at 4500 rpm. When you are sitting in your car or your bike, you have this RPM meter. Have you seen that RPM meter? Huh? On your bike, there are two round dials. One shows your RPM and the other one shows your speed. That round one, it's marked in 1000, 1000, 2000, 3000, 4000, 7000 RPM. That is what your RPM of the wheel of the car is. Actually, it does not give you the RPM of the wheel of the car. It gives you the RPM of the engine. Engine. Anyways, the wheel of a car is rotating at 1200 RPM. On pressing the accelerator for 10 seconds, it starts rotating at 4500 RPM. What is the angular acceleration of the wheels, my dear friend? Some answers are given in radians per sec square. Some answers are given in degrees per second square. I'll give you this question as an homework. Try it out. Tell me the answer in the next class. In the next class, we'll be continuing to do more questions on this. So don't worry about this. I'll see you in the next class. Till then, I hope everyone has understood what we have discussed in the class today. Yes or no? Okay, then I'll see you tomorrow in the next class and we will go ahead and solve more questions. Take care. God bless all of you. Bye bye. If there's any doubt, I am always there to catch hold of. Take care. Bye bye.